Hello, my name is Dylan. Welcome to my YouTube channel, Math and Physics for Everyone. Let's get started. This is an Atwood machine problem. Two hanging blocks attached to a pulley wheel. A 3 kilogram mass and a 5 kilogram mass hang vertically at opposite ends of a very light rope. The rope goes over a frictionless and massless pulley. A, what is the resulting acceleration of the masses? And B, what is the tension? So first, we'll start by graphing all forces. In the cord, we have tension, and tension always appears at both ends of the rope. W1 and weight 2, or force due to gravity 2. Again, this is the same tension force that appears at both ends of the rope. Mass 1 is 3 kilograms. Lighter mass goes up. Heavier mass goes down. Good. Step 1. Apply Newton's second law in the vertical or y direction to M1. So we're going to do both masses separately. So add together all forces in the vertical direction equals M1 acceleration in the vertical direction. Good, so for mass 1, we have, on the left-hand side, we have a positive t, because it points up, minus W1 equals M1 positive A. The acceleration of mass 1 goes up. Then we isolate for t by adding W1 to the other side. W1 equals M1 G. We can actually factor out an M1 because it appears in both terms, but we'll continue for now. Next, we'll apply Newton's second law in the vertical direction to mass 2. All forces acting on M2, positive T minus W2 equals M2. This is where the most common mistakes happen. This notation means take into account your sign or your direction, your vector. Mass 2 has a negative acceleration. Good, so this becomes tension equals, add W2 to the other side, M2G minus M2A. By convention, every time I do these problems, I isolate tension each time because it allows me to move over my negative values. My negative W1, my negative W2, it looks ugly. I don't want minuses or negatives floating around. And the next step is step 2. And here's another reason why I isolate for tension. If both expressions are equal, both expressions are equal to t. Therefore, they equal each other. And that sort of allows us to eliminate t, although we isolated for t in the beginning. So expression 1 M1G plus M1A equals expression 2. Good. I have multiple A's floating around. I have to collect them on the same side. So that would be M1A on the left. And I can also add an M2A. So once I collect these terms on the same side, I can factor out that A. But then I'll also have to move this term to the right side. Yeah, so I'm collecting all my A's on the left. So minus M1G. Oh, and again, I have a greatest common factor of G. So actually, let me pull that out as well. So G appears in both terms, so I'll factor it out. Good. And then A equals the difference of the masses times G divided by the sum of the masses. So A, 5 minus 3 is G divided by the sum of the masses. So acceleration is 2 times 9.81 divided by 8. So we get about 2.45. 2.45 meters per second squared. And of course, that's the acceleration of both masses because they're connected by a cord, so they move as one. And that's the process. Now, we had two unknowns, T and A. So technically, we are solving a system of equations. So now we could find that T using either equation 1 or equation 2, because part B is find the tension. So I'll use equation 1. T equals, and now it will be easier if I factor out this M1. So just to save some time, equation 1 is M1 times G plus A. 3 times G plus acceleration, 2.45. So the tension in the cord is about 36.8 newtons. Good. And again, this would be the same T value as if you used equation 2, because we did solve a system of equations. Kind of like using a substitution method or kind of the elimination method. I mean, by setting both equations equal to T, this allowed us to not have a T floating around in the beginning. We only had acceleration, and this allowed us to isolate for acceleration. So anyways, the underlying theme is there is no set in stone formula for tension, The formula for tension varies from situation to situation, and that's one of the underlying themes of physics. Um, Another important thing to remember is when you do projectile motion, typically you plug in negative 9.81. How come we didn't plug in negative 9.81? Well, when we apply Newton's laws, here, this negative sign, that is the sign of G, because W1 is M1G. So we already took into account the negative. So do not plug in negative 9.81, because then you take into account the negative twice. So anyways, this is a great Newton's laws approach to Atwood machines, or in other words, two hanging blocks on a pulley wheel. So take care, and I hope this helps.